One of the most common questions I get from people is always about the design sheets. So where'd you get them from? What do they look like? What information is on them? How do you read them? And can I have them? When I did this subloom for the Mazda FD IAT from the previous reel, I didn't really do this as a reason to talk about the design sheets, but now that I'm looking at the loom and the design sheets, this is not a terrible one to sort of discuss with y'all who have not seen these design sheets before. So if we take this loom, which is essentially about a 11-inch extension loom, so it's 2 wires here to 2 wires here, no splices, just an extension cord. So if we call this connector here connector 1 and this connector here connector 2, that corresponds with a couple boxes here that say C1 and C2. So connector 1 here, DTM 2-way, receptacle housing with a boot, right? All of that information here, including where that connector is going. In this case, it's going to the OEM IAT connector. Connector, here's the part number for your DTM04-2P. In this case, the -K is a kit, the -N is nickel solid contacts. Terminal gender, it's a pin, and a boot, if any. Now, you'll notice here this part number for this boot is RBT-DT2. If I saw this here under a DTM, I would think that that was a typo, and it should be -DTM2. But like I mentioned in the previous reel talking about this particular boot, because I have service loops under here, and this is going on a pin on the receptacle housing, or the pin side housing, this is a DTM 2-way boot. I prefer the DT because it's just a little bit larger where I can put the service loop under here and also go up and over the protruding edge there on the pin side housing. You can also cut those off with a pair of dikes. I didn't on this one, but that is not a typo. So that is actually a DT 2-way boot. Oh, one thing here I'll mention, I always forget to. When you guys put boots on these things, especially if you're using a piece of heat shrink, right? Either a piece of SCL or a piece of ADOM, take some sandpaper and abrade the outside of the housing, right? So scuff it up some to give that heat shrink something to sort of grip onto. Now, the only thing you want to be careful of is that when you do the heat shrink, a lot of times that heat shrink will actually want to walk down the housing some. So if you are going to scuff it, I wouldn't scuff it all the way to the end, because if that heat shrink does walk down some, it's going to suck down some anyway, because it's either a 3-to-1 or a 4-to-1 shrink. But if it actually pulls too, because it's sort of slick, if you scuff it, it'll want to bite better on there. That also goes with the molded boots too, if you're putting like a 202A or something on that thing. So either way, in this case, it's a DT 2A boot. Now, connector 2, which we know is the LK2 EV1 connector. Okay, this is LK2 EV1 housing and a boot. So this connector goes to the actual IAT sensor. The internal part number here, the 5-40147, that's internal part number for KSV for that connector, which is an EV1. Terminal gender is socket. So there's sockets inside that. And the boot is a Pro 90 EV. Now, you'll notice here there's a mention of a 90-degree clock. So what that means is that if we talk about this EV1 connector housing, right? If you were to ask me which was the top of the connector, okay, I would call this spring here the top of the connector. So I would say that this is the top. So when we talk about clocking, okay, we're talking about clocking of the boot. So the orientation of the boot. Now in this case here, if this connector was plugged in, the clocking is with the connector plugged in. So it's not a 90-degree clock looking into the face of the connector. It's a 90-degree clock orientated to where if the connector is plugged in. So with the metal clip here on this EV1 being the top, 90 degrees is directly to the right. If it was 180 degrees, that boot would be going straight down, etc. So in this case here, we've got the Pro 90 EV, which is that rubber boot, not to be misconstrued with the other pressure transducer boot. The LK2 EV1 connectors use a different boot, even though they look very, very similar. That's listed here. Now, there's another bag over here. Because we were having Jason, who has this Mazda FDRX7, because we're having him cut off the original OEM IET connector, he's going to need a mate for that connector. So sometimes with these design sheets, you can list the mate up here in this box somewhere too on one of the other ones, like maybe it would be up here on this actually to the OEM IET connector. There would be a little, there's another version of this design sheet which has a bit more information for more complicated builds, and they would say mate supplied here, but in this case it's a bag, right? So we just have a box here, supplied replacement. That connector that's in this bag, this is a DTM two-way plug housing, so socket terminals. So part number here for that connector, DTM06-2S-E007. The E007 signifies that little boot lip right there. So if it was just a DTM06-2S, that boot lip that I'm pointing at, that would not be there. So the connector is a little bit shorter and it wouldn't have a place for that rubber boot that we're including with the package to go on. So as you can see here with the boot, again, RBT-DTM2, that is that boot, which is the same ProWire USA boots that I mentioned in the previous reel, except this is, again, the DT family, because it's on the pin side housing. This is the actual DTM rubber boot. So that's why part number here, RBT-DTM2, the one up top, RBT-DT2. So terminal gender, again, sockets are what's in there. There's a few extras here for Jason because he's never crimped solid barrel contacts before, so we're going to give him a couple extra there so we can give it a test run before he crimps onto his vintage Mazda FD RX-7 engine loom. The other information in these boxes, each one of these this source column is what pin is, or I guess I should say which pin location on the housing. So on this DTM04-2P, if you look at this housing, there are numbers on the housing that specify which is pin 1 and which is pin 2. So in this case, pin 1, there is a black 20 gauge wire crimped onto that terminal. It goes into the pin 1 slot, and the destination is connector 2, which is the EV1 connector. It goes to connector 2, right? So we're still talking about pin 1 on connector 1, but it goes to connector 2, pin 2. So connector 2, pin 2 here. So 20 gauge black, pin 1 on the DTM, 20 gauge black. So essentially that wire goes from pin 1 here down to pin 2 here, which is on the right hand side. So one thing that sort of you got to make sure you remember when you do these is that if you have two connectors sitting right next to each other, pin 1 on this DTM may be the connector, or I'm sorry, maybe the pin on the left, whereas on this connector, the pin on the left may be pin 2. So the important thing is that you get them where you want them to go, but that's why you may have a pin 1 going to a pin 2. These are both 2A connectors, and if you're asking, well, it's just an extension cord, why would pin 1 go to pin 2 on this connector? I thought pin 1 would go to pin 1. Well, these are different connector families, DTM and the EV1 family, which is an Amphenol connector. So that's why pin 1 here goes to pin 2 here to keep everything nice and happy. So same thing here for on the DTM connector. Again, the DTM connector, and now we're talking about pin 2, that goes to connector 2, pin number 1. So in this case here, that is a 20 gauge green, and then that goes to pin 1 in connector 2. Shows where it's from, 20 gauge green. Now these functions here, normally this would be the actual technical function of the conductor. Here, I don't know what they are, so it doesn't matter. I'm just making an extension cord. So they can be apples and oranges, can be the functions. It really doesn't make a difference. But here on the supplied replacement, this pin 1 will correspond to the pin 1 here. So because these are the same family, right? So we have the supplied replacement, which is the DTM 2-way. So the supplied replacement mates to connector 1 on the loom, which is the DTM 2-way. So that's why these do match. So pin 1 on the DTM 2P is a 20 gauge black, and that will also be the case for the supplied mate, assuming that the OEM loom, which I believe I have these colors accurate. If I'm not, I'm sorry, Jason. That's why pin 1 here, 20 gauge black, is going to a pin 1 here on the DTM, because these are actually the same. So if you took a DTM connector and you plug these in, you know, pin 1 and pin 1 go together, and pin 2 and pin 2 go together. Other information on the design sheet here. So wire cut list. In this case here, there's only 2 wires that were cut. Even though the whip is around 11.5 inches long or whatever, the wire length is cut longer. You know, you've got a twist in the loom, you've got service loops, you've got to have room to crimp. So they've always got to go longer. DR, this is really, when you talk about accurate measurements, the DR cut length really is a big driver in terms of the when we're talking about what's the length from A to B. The DR is a very critical measurement. In this case, it's just 10.5 inches of 8, and your 2 pieces of SCL cut list here. So those are what's going on. Those are what's going on. I always get people ask me the difference between SCL and ATEM. So this SCL, if you can see, this SCL this is hard. If this was ATEM, this is a bit more soft, and it has a grayer look to it. It's not black, so, or at least it's not that dark of a shiny black. And you can see too on this adhesive line tubing, when you have it, let me see if you can sort of see it splooging out of the side there. That, let me see if I can zoom in. It's not really zooming properly, but you can see it there. You can see the glue actually start to come out of the adhesive. So when you see that, you know that thing's been recovered enough. And also when you do these back sides of the boots, this is a pretty good step down. Some people will put another piece of shrink here and shim this to where this doesn't have to step down as much. But you can also take, while it's hot, you can give it a squeeze with either a pair of needle nose or with your fingers, or if you're wearing gloves or something like that. And you can actually squeeze that down if it doesn't come down quite as much as you're looking for. So, but either way, I could probably talk for another hour just about this design sheet on this extension cord. So if you guys have any particular questions about them, let me know. I'll try and answer them.